I am very excited to be here. I also realize I am what stands between you and dinner. So I'll try not to make it too hard for you. I am super excited to share about Passkeys with you and WebAuthn. I've been working, building a very important feature at our startup around this technology, and I've learned a lot of good things. And I hope that you guys can learn a few things about it and feel confident enough to implement it in your own applications if you choose so. Can you hear me okay? I'm not sure. Okay, awesome. Thank you. Okay, so if you want to follow along with my slides, go ahead. You can scan this QR code, and it's going to follow in real time. Sometimes you want to stop and maybe read what I put, maybe find typos. I promise I double-checked. But you can go back to. You don't need to just wait for me to pass the slides. All right, I'm going to give you another second, and I'm going. Okay, so this is what we're going to cover today. You can definitely read. All right, so I'm going to talk about what WebAuthn is, if you're not familiar with that term. We're going to talk about what passkeys are, create a distinction there, talk about some of the problems it's trying to solve, etc. I'm not going to go over user session or even credential management. I think this depends on your business logic, really. Now I'm going to go over this very interesting thing called Passkeys extension, how you can tell the browser, the client, how to extend some of the functionality that the API has and do some cool stuff with it. I'm not going to talk about that, though. And I'm not going to go super into depth into every little option and configuration you can create when you're requesting passkeys or when you're building it. We're only going to go a very simple flow of registration and authentication. All right? Okay, so what is the problem that Passkeys and WebAuthn are trying to solve? Let's take a look. This is from Cyber News, the most common passwords this year. You can see, you can think whatever you want, whether this is actually a representation of your users or this is maybe just bots. But convenience or remembering passwords is something that is on the mind of the typical user account. Here's another. This is from Google and Harry Spoll. What baffles me here is that about 40% of people say that they had their data compromised somehow, but less than half are willing to do something about it, change their password hygiene or change the passwords. So pretty alarming things. And then the next one, this is from 2021, a little bit older, but 2 out of 3 people reuse passwords between accounts. If you're guilty of that, no shame. It's really hard to come up with really good passwords and remember them. Although I will say there are things called password managers out there. You should try it. Anyway, passwords are the problem. And you can change passwords here basically with anything that relies on a factor of knowledge. A secret, something that you expect that only that user will know. Okay, so this is a proposal with WebAuthn. No more shared secrets. Authentication is no longer going to rely on some secret knowledge that you expect the user to know, but it's going to rely on very safe mathematical properties. So it relies basically on asymmetric cryptography. You basically have a key pair. When your server is going to take that public key, and your authenticator will hold a private key. And then whenever you need to authenticate a user, you're going to use your public key, sign a challenge, and then you're going to pass that to authenticator, and the authenticator will get to the private key he has, and will sign that challenge, and then send back to your server, and your server can determine whether the challenge is accepted now or not. Okay, that's basically it. That's the whole point of WebAuthn. It's just like, hey, let's not rely on the user's biometrics. Let's not rely on the user's access to some account or passwords. Let's just rely on something that we can actually prove with math. Okay, so Asymmetric cryptography, no problems with key 1, W2, E3, R4 passwords. Servers only store a public key. So even if there is a data breach on your server, the hacker or whoever's trying to get access to your data can't do anything with it. And then the last thing is, this is the important part. A WebAuthn credential can only be used and will only work on the apps that it has been registered for. So if I create a WebAuthn credential for google.com, I will never be able to use that credential on facebook.com, for example. So that helps with phishing, for example. All right? Okay, now I've been throwing this term around. If you're not familiar with it, WebAuthn stands for Web Authentication. It is a specification and an implementation, practically. Your browser implements it. And all it does is specifies data models and some APIs that the browser will use to communicate with an authenticator. And I'm going to go over that in a second, to create WebAuthn credentials and use this paradigm of public key cryptography. Okay, it's a standard, and it's a standard that was written by the FIDO Alliance. These are the guys behind Ubico security keys, or those hardware keys that some of you are familiar with, and the W3C, which is they write standards for the web. This is the support for WebAuthn currently. Pretty good. I don't know if you can see, it's a little bit small, but it's about 93% global usage. So unless you're using Internet Explorer, if anyone does that yet, you should be okay. Okay, so what's a passkey? When you see these terms scrolling around in the web, you're gonna start to notice that passkeys and WebAuthn are being used interchangeably most of the time. There is a little difference that you start noticing. WebAuthn or a WebAuthn credential is used in a context of we're just creating this public key cryptography depending on authenticator, and that's it. Now a passkey, it's a credential just like a normal WebAuthn credential, but the difference is it's supposed to be using during a password's authentication, right? So the key on the authenticator is created in such a way that the authenticator can then the client, right, or your server can then specify, hey, you can log in with passkeys on this website, and then just give me a key, and then the authenticator will then tell the user, look, I have all these keys available to log in on this website. You can choose which one you want. And then basically you enable this idea of passwordless authentication. And to some point, and we're going to talk about that, even no username authentication as well. For the purposes of the talk, that's how we're going to refer to them. WebAuthn, I'm always going to be talking about WebAuthn as a spec, and I'm always going to be talking about passkeys as the actual credential that the user is using to log into your application or your website. All right. The specification specifies 2 use cases. Actually, it specifies 3, but we're going to focus on these 2, which is registration, creating the credentials, and then authentication or verification and some other terms you can be seen around. And this is what it looks like. Now, before we go too deep into that, let's start simple. We talked about this is registration. You have your authenticator, which in this little image represents the user and the actual device they're using. And then you have your relying party. A relying party is a fancy word for verifier, okay? And the relying party is your website, your application. So to registration is, hey, I want an account. The relying party will say, okay, I need a public key. And then the authenticator will create a key pair, with the authorization of the user. Here is a common misconception when we think about passkeys, is that sometimes it may give you the impression that we're actually using the biometrics or the PIN code in Windows, for example, or the Touch ID in Apple S to actually log in. That's not what's happening at all. the authenticator prompts the user to authorize it to create a key pair. And the way it does usually comes in the form of a gesture. And then the gesture depends on the authenticator or the operating system. For macOS, that usually will be Touch ID. So that's the gesture the user needs to do to the authenticator, say, create a key pair. For Windows Hello, could be just your face, and it opens up the camera and it scans your face, right? But all of that data is not embedded into the key pair that creates. That's just the user telling the authenticator, hey, you're good to go, create a key pair. All right? Authentication, again, relies only one thing, cryptography. Anyway, creates the key pair, sends it back to the relying party, and then registration is complete. With authentication, it's a similar process, especially when you're actually writing the code for it. The difference is that the key pair already exists. And when the user and the authenticators claim, like, hey, I want to get in your website, I want to sign in, then the website will determine whether the user can or not sign in, but usually it will then create a challenge and then send that challenge back to the authenticator. The authenticator will sign with the authorization of the user. The user will make a gesture so the authenticator can continue. And then the authenticator signs the challenge, sends it back, and then the relying party can verify that signature using the public key. And yeah, if everything checks out, then you can put your business logic here, maybe create a session for the user, maybe set a cookie, create a JWT, whatever you do to log in users. So now we can go a little bit more into depth. These are the different parties involved in the use cases. We have 4. We have a user, the client, and the server, which we were talking about them as the relying party, and then the authenticator. It's a data flow, really. It just starts with a request that the server creates, and basically forwards it to the client, and then the client, the browser, or your application, will then prompt the authenticator to start all the cryptography magic that it has. The interaction between the user and the authenticator really is just the gesture. Just the authenticator, hey, I have this request, am I good to go? And then the user will do the gesture and clear. All right, so I have a demo for you guys. You can scan that if you want. It's a very, very simple. Here it is. It's a very simple application where a user can sign in and a user can sign up. So if I come here and I put my name or just a test email, like, I don't know, I will put test 9000 because I don't remember how many times I test this. Yeah, I'm not doing any validation, so it doesn't matter. So John, for example, I'm going to sign up with a passkey. So I requested the server. I want to sign up. I want to sign up. The server prepares the request, sends it back to the browser. The browser now is prompting the authenticator, which is macOS, to create a passkey. Now I can choose. That's the beauty of it, is that I can tell I don't want the OS thing. So the next level is the Chrome browser. So Chrome is telling me that I can create this passkey in my Chrome profile. I can create this passkey with my Pixel 8 phone. And I could just click iCloud keychain, and then would pop up the same pop-up that I closed. Or I can just use whatever device I want through a QR code. For simplicity, I'm just going to go back to my iCloud keychain. And I'm going to authorize the authenticator that it's on my operating system. And there you go. I was registered. And then I can come here, and then test 90? I should probably remember that, but whatever. Let's try that. And then, all right, so it was that. And then I can just authorize that, and I'm in. And obviously, I'm not creating a session. If I refresh, all of this is going to disappear. But that's pretty simple. In code, the way that looks like is this. Let me make it bigger. All right. So here I have a client, the code that's running my client, running my browser. I am using a sorry, I'm trying to find the right function here. I'm using a library called simple WebAuthn for the browser. You can use the native browser API. So if you go here, you can say navigator, for example, dot credentials, and then I can create the credential I want, and then you see credential creation options, and then I can pass the options that I need, and then it will do everything that this function over there is doing. Why I'm using a library here, it's for the purposes of data encoding. Some of the fields that the API and the browser expect needs to be encoded in a specific way. Some of them expect base64 URLs, some of them expect uint8 arrays. So this library, if I'm using this library in the client and on the server, I am good to go. The encoding will be consistent. That's the option that I'm making here. But it's simple with the idea that I will make a request to request the registration options to this endpoint, which ends up being called in this function. And then, you know, like I create a user, I tie the email to the user, all that fun stuff. But then here, this is the options for the registration. And I'm going to highlight some important options. These two are pretty important, especially our PID. This is how the authenticator will know the scope of your key. I think that's the term they use on the specification. And if I look at my constants, I'm setting the PID to be either localhost if I'm running locally, right? Or this variable here, which is just my domain name, which in this case is passkey.lucasmnrc.dev. And now, any passkey that has that RPID as part of it will be able to be used in my server. If any passkey doesn't match my origin, my domain name, then I can't use it. IP name, this is arbitrary. You can use whatever you want to identify it. User ID, again, needs to be in a specific encoding, but this is just tying this passkey to a specific user. I can put some information about the user here. This is for how long will this challenge be valid. So after a minute, even if the user authorizes the authenticator to go on, then it will fail. I will say the client can override this at any time. So this is not like a hard requirement. Now these two are kind of important for the context of passkeys. The whole idea of passkeys is that at the authenticator level, not at the relying party level, at the authenticator level, they are discoverable to the user. In order to do that, you have to tell to the authenticator that the key pair that it's going to create is what we call a resident key. So it is essentially, you can think of it as that key will live in the authenticator. Non-WebAuthn credentials, if you don't care about passkeys at all, no, it's just you want to do like a multi-factor authentication flow with passkeys. What you would do, you would just omit this or say, I don't remember what is the value that I need here. Let's see. Oh yeah, discourage. If you do that, what happens is you will store some information. You will have to store some actual information about the credential on your database, and then you would have to recreate that key each time the user needs to authenticate. That's not a passkey flow at all. Remember, passkeys is the whole idea that I'm doing authentication without passwords and possibly without usernames. So you want the authenticator tell the user that that there are keys that the user can apply to this website. So you can say, actually, the word I use here is required. So if you want actual passkeys to enable passwords authentication, you have to require that key pair is a resident key. User verification, it's the idea that the user needs to approve the authenticator generating the key pair. If I would say that this is discouraged or I don't need it, then the authenticator would simply create a key pair and go on without asking the user anything. I'm saying here preferred to tell that if for some reason the authenticator cannot verify the user, like not that the user doesn't want to be verified, but the authenticator can't create a gesture request, then it's okay. It's going to create a key pair anyway. And then on the verification side of things, you can request that again, and maybe you have better luck there. And then the supported algorithms. This is the algorithms that the hardware will use to generate the key pairs. I think this is RSA, and I forgot which is the other one. But if you go to MDN docs and look for the WebAuthn documentation there, you will tell exactly what different algorithms you can use. Anyway, I create the options, and then these options will have a challenge here. I am saving that challenge to use later, and I'm tying that challenge to the user that I just created. And then I go back to the client. Eventually, these options are going to end up over here. And I am just requesting, this is the extension that I mentioned in the beginning. I'm just requesting, hey, give me some additional information about this credential. And then I start the registration. This is the call from the library, passing the options that I got from my server. And then once that registration is cleared, I send that back to the server. And then the server will process that. And from here, it's pretty straightforward. I retrieve the challenge, and then I verify the response that I got. And again, I'm telling, this is my expected challenge coming from my database. This is my expected origin, which is the domain name that I have. And these two are the same for this context. And then I'm saying I actually want a user verification. So even if you couldn't get a user verification, the whole process here would fail. Okay. Once that's passed, if it's not verified, then obviously didn't register anything. But if everything checks out, I'm just going to save that public key as a credential in my database. I have the public key right here. I have the ID of that credential, and then the transports, meaning what kind of authenticator essentially it was used to this credential, and then my user ID. For authentication, code is similar with a few important differences to point out. Here, allow credentials. That's the most important option, I would say, when you're creating an authentication request. You're going to go through your user's credentials, and you're going to map all the credentials that the user has. And then the authenticator with that will know which credentials to show the user, possibly, or just which credential to get based on what your website tells the authenticator, right? Your website can say, hey, I have these following credentials with these IDs. Do you have any of them? Or do you have all of them? Now, this is the interesting part, because remember, I have set resident key to be required. I don't necessarily need to be doing this. I am just doing this for precaution right now. But this is more of a flow of non-passkey credential, okay? But also my case here on this example, my user can only have one passkey per account, so it will always be the same thing. But yeah, like I just generate the options like this, not a lot of things. Here, it's important that the user actually approves before it actually signs the challenge. On the client side, same flow. I ask the server to create a request. I get the results of that and forward that to my authenticator through this function over here. And then I just forward the results of that back to my server, and then my server ends it. And here are the options. And this is the information about my credential, that the authenticator itself signed a challenge with it. Here's the challenges and all of that. If everything checks out, I obviously am going to verify that. And then a very cool thing. From this authentication, I can get a counter. Every credential has a counter. So every time I verify a credential, that counter increments automatically. Why is that? Well, in the possibility that your device gets cloned, this is how you can have some suspicion that credential is a clone credential. Because if you expect that your counter is one thing, but then you're getting like a really big difference on your new counter, you can suspect that this is not the actual credential that was originally created. Is this something that you can trust 100%? I don't know, honestly. But looking into the counter, that's the idea behind it. It's to try to detect cloned devices by just checking the differences between counters. All right, and then that's it. If everything checks out, you can then create your session here. You can generate a JWT. You can set up a cookie, and move forward. We're going back here. Full screen. This is specific about my implementation. All right, not necessarily with the spec, but we can go into that if we have time. But you should, I'm not doing this, but you should probably design your registration verification flows around the idea of sessions. You probably want, whenever you are creating a passkey, you probably want to create a passkey session, essentially, that will actually expire, that if there is a failure, you will actually handle that failure. Right now, on this implementation, if for some reason my registration fails at some point, I'm not deleting the challenge. The challenge exists. And it's right now in this implementation, if this happens, I can't register that user ever again, unless I go to the database and delete the challenge manually, right? So design these things around an idea of session. I know I said I'm not going to talk about sessions, and I'm not. But when you are going to implement this, really design it around it, okay? And the second point, is probably the biggest criticism on passkeys, is that if the user loses access to the device, or if the user loses access to the passkey, the user loses access to the account. I will say, though, that that's true for every credential that exists in authentication. If the user loses access to a password, the user loses access to the account, right? How to mitigate that? Well, then you can tie an email to the user, or you can still require some kind of multi-factor authentication and use passkeys as a fallback, or use some other factor authentication as a fallback. Basically, to solve that is handle this the same way you would handle any other kind of credential that a user loses access, right? If the user loses access to their Facebook account and you're accepting them to log in with Facebook in your app, well, they have to recover their account with Facebook, right? But so I don't really get the point of this criticism. You just need to think about that. And that possibly means that you can't create a very robust no username flow, because you need some information about the user at some point to be able to tie it back to him and recover, right? Okay, and then the other big, a huge weak point on this spec is the whole idea that an RP cannot look into the authenticator and see the available credentials. If the RP could do that, the RP could make suggestions to the user and say, hey, log in with this credential that you know you have. So the RP has no idea what the authenticator really has inside of it. And you could say that that's actually good. It's a little bit more safe. But there are some implications with user experience. And if you have questions about it, or if you have thoughts about it, we can chat later. And this is some of the resources I've used. I'm going to shout out some of my coworkers. They're not here, unfortunately, but they really were ruthless in giving feedback about the stuff that I said here, and informed a lot of the things I talked to you guys. So thanks, JP and Josh, for watching this. I really appreciate it. But another good resource, if you just want to learn about full stack authentication in general, is Max Furtman. He's giving a talk right now in another theater. And his course in Front-End Masters about authentication is really good. He goes over passkeys and talks about some of the stuff I talked here. And then, obviously, if you are the kind of guy who likes to read specifications, the WebAuthn spec will have everything you need to understand this technology better. I'm going to be around. If you have any questions, I'm happy to take them here, or you can chat with me in the corridor. You can find me there. Thank you so much.